Welcome to this episode of AI Frontiers, exploring the robotics revolution. Learning to walk, perch, and navigate like pros. This synthesis covers 29 papers from July 8, 2025, delving into the latest breakthroughs in autonomy, adaptation, and real-world applications in computer science. Robotics. Imagine robots learning like babies or perching like birds. These are real advancements from yesterday's papers. In this presentation, the field is explored, along with key themes, findings, methods, standout papers, and future paths. This engaging narrative blends technical insights with storytelling to spark curiosity about intelligent machines. It is perfect for enthusiasts and newcomers alike, highlighting how AI gives robots smarts and agility. Computer science. Robotics fuses AI with hardware to create systems that perceive, plan, and act in real environments. Inspiration is drawn from machine learning, engineering, and biology for intelligent agents beyond mere tools. This field revolutionizes healthcare, manufacturing, exploration, and disaster response with autonomous capabilities. Challenges are faced, such as the sim-to-real gap, where virtual training meets messy physical uncertainties. These 29 papers emphasize learning and adaptation, testing AI in dynamic, unpredictable settings. A key theme is learning from demonstrations, where robots imitate humans to master skills efficiently. Another focuses on evaluation and benchmarking, drawing from psychology for robust assessments. Path planning under uncertainty enables navigation in complex environments like caves or roads. Specialized capabilities address challenges like perching or grasping in dynamic settings. These themes interconnect, driving adaptive robotics, supported by evidence from the papers. Theme 1 centers on learning from demonstrations and imitation, mimicking humans for skill mastery. Robots learn manipulation from unlabeled videos, handling occlusions and deformables, as detailed by Chen and colleagues. Bilateral teleoperation enables low-cost arms to copy human actions in real time. Imitation learning, a core concept, transfers skills via neural networks, reducing the need for coded rules. Efficiency is boosted in tasks like grasping, with applications in warehouses and homes. Evidence shows up to 80% improvement in non-displacement tasks, democratizing robot training. Theme 2 involves evaluation and benchmarking of behaviors, assessing like human development. Inspiration is drawn from infant psychology to evaluate bipedal locomotion with fine-grained metrics, as explored by Crowley and colleagues. Neural networks benchmark imitation in humanoids for safety and robustness. A key concept is that behavioral metrics reveal nuances, like gait adaptability, beyond basic rewards. Robots are ensured to be reliable in uneven terrains, such as search and rescue operations. Papers highlight 30% more insights from exploratory training regimens. Theme 3 encompasses path planning, navigation, and specialized capabilities, adapting to uncertainty and environments. Lagrangian relaxation solves constrained paths with zero-duality-gap for uncertain navigation. Aerial robots learn tensile perching from demos for energy efficiency, as presented by Yuan and colleagues. Model predictive control is explained as real-time optimization under constraints, handling perception uncertainties. Feats are enabled, like underwater mapping or zero-shot 3D reconstruction in cluttered scenes. Specialized tasks are supported, from medical bots to racing vehicles, enhancing real-world autonomy. Key findings provide critical insights across the papers. Exploratory training yields adaptable bipedal gaits, uncovering 30% more nuances, as found by Crowley and colleagues. Embodiment-centric flows boost manipulation by 80% from unlabeled videos, according to Chen and colleagues. Tensile perching doubles drone endurance, mastering agile trajectories, per Yuan and colleagues. Large language models achieve 93% route completion in edge case driving via reasoning. Ultrasound systems enable error-free venous catheterization with under 2.15 mm accuracy. Methodologies synthesize the approaches used. Reinforcement learning from demonstrations, like soft actor critic, trains via rewards and expert data for agility. Imitation learning with neural networks mimics videos for efficient skill transfer and manipulation. Model predictive control optimizes paths in real time, ensuring safety amid uncertainties. Visual-inertial odometry fuses sensors for robust mapping in GPS-denied environments. These hybrid methods blend AI and classical techniques, though data intensity and computation remain challenges. The first selected research paper is titled, Evaluating Robots Like Human Infants, a case study of learned bipedal locomotion, by Crowley and colleagues. It was selected for its novel psychology-inspired evaluation, impacting training assessment. Infant development metrics are applied to simulated bipeds, revealing exploratory training's benefits. Findings show that flexible gaits are yielded, bridging sim to real gaps for rescue robots. Significance lies in humanizing design, inspiring curricula for broader skills with ethical simulation advantages. The second selected research paper is titled, EC Flow, Enabling Versatile Robotic Manipulation from Action in Labeled Videos via Embodiment-Centric Flow, by Chen and colleagues. It was chosen for innovative data efficiency, tackling occlusions and deformables representatively. Flows are predicted tied to robot kinematics from videos, translating to actions without labels. Findings indicate an 80% boost in non-displacement tasks, generalizing broadly. Significance includes lowering barriers for assistive tech, scaling from abundant in-labeled sources. The third selected research paper is titled, Learning Agile Tensile Perching for Aerial Robots from Demonstrations by Yuan and colleagues. It was selected for its energy-optimizing novelty in aerial robotics, a key direction. Reinforcement learning with demos is used to master tether wrapping on structures. Findings demonstrate high success in agility, outperforming baselines and handling variations. Significance extends mission times for surveillance, inspiring hybrid aerial systems. Future directions outline the next steps. Hybrid eye classical systems and bio-inspired designs, like infant mimicking walkers, will advance autonomy. Large language models are integrated for intuitive human-robot interactions, with focus on sustainability for eco-friendly bots. Challenges are addressed, including data efficiency, generalization, and real-time edge computing. Bio-AI fusions, massive in-labeled datasets, and improved sim-to-real models are expected. The vision includes robots collaborating in hospitals or exploring oceans, enhancing human capabilities. This synthesis was created using AI tools, including GPT Grok using model Grok 40709 for content generation. TTS synthesis was handled using Google for audio, and image generation was performed using OpenAI for visuals. While the synthesized content underwent review by a human expert, it is important to acknowledge that some oversights may still exist. All references are provided for further reading and verification. Subscribe to the YouTube channel for more deep dives into AI and robotics breakthroughs. The channel is AI Frontiers, your go-to for cutting-edge research stories and innovations. Hit that subscribe button and turn on notifications to stay updated on daily paper syntheses. Share your thoughts. What robot innovation excites you most? In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.